We have already solved question 1, 2, 3 of the 0620 question paper 4-1 of the examination series October-November 2024, and now let's go ahead with the remaining questions. So let's start with question 4 now. When magnesium nitrate is heated strongly, magnesium oxide is formed. So magnesium oxide is formed here, which is shown here in the equation. So the equation, balanced equation, is also given here, and the question, sub question 1 is state the change in the oxidation number of nitrogen N in this reaction. Now here we need to calculate the oxidation number of nitrogen here and the oxidation number of nitrogen in nitrogen dioxide. So if we calculate the change in the oxidation number, nitrogen NO3 minus, now putting X for the oxidation state of nitrogen and then calculating oxidation number of oxygen, that is 3 into minus 2, will give us an overall charge of minus 1. So here, and if we calculate that, X is equal to plus 5, right? So here we have nitrogen in the oxidation state of plus 5, and if we calculate in a similar way for nitrogen dioxide, keeping X 2 into minus 2 is equal to 0, then we get the oxidation state of nitrogen here as plus 4. So the change in the oxidation number is plus 5 to plus 4. Now sub question 2, identify the element which is oxidized in this reaction. Now we can see that the nitrogen has been reduced from plus 5 to plus 4. The oxidation state decreases. So which one is the one which has been oxidized? That is, the oxidation number has increased. Now if we check that, magnesium is plus 2 on the reactant side and plus 2 on the product side. So what is left over? What is left over here is oxygen, where oxygen is minus 2 with the nitrate, but elemental form it is 0. So the oxidation number of oxygen has increased from minus 2 to 0. So oxygen has been oxidized. So we can write oxygen is the element which is oxidized in this reaction. Now let's go ahead with the next part, calculation. The third is calculate the volume of nitrogen dioxide gas at RTP formed when 7.40 gram. Understand, this is 7.40 gram. That's the mass of magnesium nitrate is heated. Use the following steps. Calculate the relative molecular mass of magnesium nitrate. So magnesium, we can look into the periodic table and find out that the AR, that is relative atomic mass of magnesium, is 24, plus nitrogen is 14 and oxygen is 3 into minus 2, because here it is O3, and the whole has to be multiplied by 2 to 4 because nitrate is twice. So if you calculate this, we get a total of 148. So this is the MR, that is relative molecular mass of magnesium nitrate. Now calculate the number of moles of magnesium nitrate used. So here we are given the mass. So moles is equal to mass upon MR. So mass is 7.40 divided by the MR, which we have already calculated, that is 148, and here we end up with the moles, that is 0.0500. So this is how we calculate the moles, that is mass divided by MR. Let's see what's the next part. Here it says determine the number of moles of nitrogen dioxide formed. Now if we look at the equation, we can see that compared to magnesium nitrate, which is twice here, nitrogen dioxide is 4 times, right? So that is a 1:2 ratio. We can say that 2:4 is a 1:2. We can say that. So if the moles of magnesium nitrate is 0.050, then for the moles of NO2 we need to divide that by we need to multiply that by 2 to get the moles of nitrogen dioxide, because it's 1:2 ratio. So nitrogen dioxide moles are twice the moles of magnesium nitrate. So if you multiply 0.05 multiply by 2, we get 0.100. So here we write 0.100 moles of nitrogen dioxide. Now it's written, calculate the volume of nitrogen dioxide gas in centimeter cube at RTP. Now remember, this is centimeter cube. Now if we have volumes, we can multiply volume is equal to moles into 24,000. Now if we want to calculate the volume in dm cube, we just need to multiply by 24. But if we want to find out in centimeter cube, it should be 24,000. So it's 0.100 multiplied by 24,000, which is equal to 2400 centimeter cube. So here we calculate the volume, that is 2400 centimeter cube. The B question is, magnesium oxide MgO is an ionic compound. Complete the dot and cross diagram in figure 4.1 of the ions in magnesium oxide, that is Mg 2 plus and oxygen, that is 2 minus. Give the charges on each of the ions. Now magnesium, if we know, it's the electronic configuration of magnesium with atomic number 12 is 2, 8 and 2. So it's going to lose these 2 electrons out. So it will be left with the 2 shells with 2 and 8 electrons. So if we draw it here, my shell is not exactly circular, but you can manage. Here we need to add 8 crosses for magnesium, because in the second shell it has 8 electrons. So it's done. Now as it has lost 2 electrons, the charge is a +2. If we talk about oxygen, the atomic number is 8, so it has the electrons 2 and 6, and it's going to have 2 more electrons from magnesium. So the outer shell will have total of 8 electrons, but 2 from magnesium. So let's draw one more shell for oxygen, and it should have 6 electrons of its own, that is 6 dots, but 2 crosses because it has got 2 electrons from magnesium, and as it has gained 2 electrons, the charge is -2. So this is how you complete the dot and cross diagram for magnesium oxide. Now next is oxygen is a covalent molecule. Complete the dot and cross diagram for the molecule of oxygen, that is O2. Now the inner shells have been drawn. Now the outer shell, as we know, it has 2 and 6 electrons, but it needs 2 more electrons. Now to get 2 more electrons, it should share out of 6 2 of its own electrons also. So let's draw 2 electrons of oxygen in the sharing area out of 6. So the remaining are 4, which will draw in the outer area, where that is a non-sharing part. For this other oxygen atom also the similar 2 crosses in the sharing area and the 4 crosses outside the sharing area. Now this is how O2 molecule is formed, that is O with O double bond O, because here 2 electron pairs are being shared. So dot and cross diagram of oxygen is over. Let's go ahead with question 5. But before we go ahead with question 5, let me tell you, we have an app for IGCSE chemistry on camscience.in, because this is the app where you get an ample of resources with lots of notes, videos, MCQ and subjective revision material, that is the questions. You also get a revision test of your own topic choice, also the past papers and lots more. So just go ahead on camscience.in and download this app, where you get the IGCSE tab, and inside you will get lot more resources. So let's start with question 5 now. Hydrogen is the first element in the periodic table. Hydrogen is used in the fuel cells to produce electricity in the vehicles. Name the substance which combines with hydrogen in the fuel cell. Now oxygen is the substance or the element which combines with hydrogen to form water and produce lot of energy. Second part is, give one advantage and one disadvantage of using the fuel cells instead of gasoline in the vehicle engines. The advantage is that water is the only product, or you can say no pollution, because there is no other product formed. So water is the only product. That is the most wonderful advantage. What is the disadvantage is that it is difficult to store hydrogen. Because hydrogen is flammable and it has to be stored with a compressed form in a cylinder, so difficult to store. That is a disadvantage. The B part: hydrogen gas can be made from petroleum by a two-step procedure. Petroleum is separated into different components, and the large molecules obtained in step 1 are converted into smaller molecules, including hydrogen gas. Now name the process used in step 1. Step 1 is petroleum is separated into different components. Now that is done by fractional distillation. So fractional distillation is the process which is happening in the step 1 to separate the different components of petroleum. The part 2 is name the process used in step 2. Now step 2, what is happening? Larger molecules are broken down into smaller molecules, and that is called cracking of the molecules of hydrocarbons into smaller ones. Here we have an organic compounds contain hydrogen atoms. Calculate the number of hydrogen atoms in 44.0 gram of ester methyl propanoate, and the formula is given here. 1 mole of methyl propanoate contains 6.02 into 10 power 23 molecules. Now that is but obvious. Any substance with 1 mole have this many number of particles. Now what are we supposed to calculate? Calculate the number of hydrogen atom in 44.08 grams. So the first step is we'll calculate the moles by the formula N is equal to M upon the molecular mass. Now for that we need to calculate the molecular mass, where we can calculate the total mass, where carbon atoms are, you can say 4 carbon atoms. So 4 into 12 for carbon. Then hydrogen, we can see that there are 8 hydrogen, so 8 into 1 for hydrogen. And oxygen, we can see there are 2 oxygens, so plus 16 into 2. So that is the relative molecular mass of the ester shown here, which is equivalent to 88. So 88 is the relative molecular mass of the ester here. So moles is equal to 44.0 divided by 88, and that is 0.5 moles, right? 0.50 moles. So this is how we get the moles of the ester shown here. Now we know that the 1 mole contains 6.02 into 10 power 23 molecules. So how many molecules will be there into 0.50 moles? So in 0.50 we have 6.02 into 10 power 23 number of molecules we have. So this many number of molecules will be there of the ester in the moles, but we need to calculate the number of hydrogen atom in the moles. So now each molecule have how many? 8 hydrogen atoms. So in one molecule, this gives us the number of molecules. Now one molecule have 8 hydrogens, so again multiply by 8, and this gives us the answer as 2.408 into 10 power 24. So 2.408 into 10 power 24, we have written it to 3 decimal places. You can even write it to 3 significant figures also. In that case we'll end up with 2.41, but here I end up writing with 3 decimal place, that is 2.408 into 10 power 24. Now you understand, I hope. The moles is multiplied by the Avogadro's constant, that is 6.02 into 10 power 23, to get the number of molecules in this given mole. Now per molecule contains 8 hydrogens, so again we need to multiply by 8 to get the number of hydrogen atoms present in 0.50 moles. So here we end with this question, sub question, and the next sub question is For each of the homologous series shown, name a member that contains 6 hydrogen atoms. Now if we have alkanes, then we have the formula CnH2n plus 2. Now this should end up with 6. Now that is possible only when the n is equal to 2. That is, n is equal to 2, then it is the ethane molecule. Ethane will have 6 hydrogen atoms. Here it says name the member. So we are just naming, we are not giving the formula. Now for alkenes, we have the general formula CnH2n. Now 2n should be equal to 6, so n is equal to 3. So if n is equal to 3, then it is propene. Propene, that is alkene with 3 carbon atoms, that is propene. Now alcohols have a formula of CnH2n plus 1 and 0H. Now 2n plus 1 plus H, that is 2n plus 2, should be equal to 6, and that is possible again when n is equal to 2. So the answer is ethanol. Ethanol, that is an alcohol with 2 carbon atoms. Carboxylic acid, again it has a formula of CnH2n plus 1 COOH. Now this should be equal to 6. That is possible only when here Cn is 2 plus 1 carbon here. So it is 3 carbon in total, 2 plus 1 of this, so that is propanoic acid. Propanoic acid is the one which will have 6 hydrogen atoms. Let's see what is there in the eke part. Okay, unsaturated alkenes are converted into saturated alkanes by the reaction with hydrogen gas. State why alkenes and alkanes are called hydrocarbons. They are called hydrocarbons because it has or it contains only carbon and hydrogen. So molecules with only carbon and hydrogen are called hydrocarbons. So here we have the answer. The second part is state why alkenes are unsaturated. They are called unsaturated because it has at least one C double bond C into it, and that's why it is called unsaturated. Now all single bonds, they are called saturated, but if it has double or triple bond, then the hydrocarbon are called unsaturated. So alkenes have double bond, and that's why they are called unsaturated hydrocarbons. Now third part is name the catalyst needed to convert alkenes into alkanes. That is, the reaction of alkenes with hydrogen is going to produce alkanes. Now the catalyst needed here is nickel catalyst. Okay, fourth part is explain why the conversion of alkenes into alkanes is an addition reaction. Now in addition reaction, we know there is only one product. And that's why it is called an addition reaction, because 2 or more reactants are just added up into one molecule, and that's why that's called addition reaction. So it has only one product, and so it's an addition reaction. Now if we go ahead with the next question 6, that is natural polyamides are polymers made from amino acid monomers. So here natural polyamides are made of the monomers amino acid. Okay, state the type of polymerization reaction that occurs when the natural polyamide forms. Now we know that the polyamides and polyesters are made up of the condensation polymerization. So condensation polymerization is the answer of that type of polymerization. The other type of polymerization is addition, but that is not possible here in the polymers. Okay, state the term given to the natural polyamides, and that is proteins. Amino acids join up to form the protein, so we call it as proteins. The C part is an amino acid is represented as shown in figure 6.1 here. So there is some carbon chain in between where it is amine group on one side and the carboxylic group on the other side. Now complete figure 6.2 show general structure of an amino acid. Show all the atoms and all the bonds in the functional group. Now here we can see that there is a carbon atom in between, and we already know that there is an amine group on one side. So just show the bonds with the amine group. Here in general we can write some R group because that can differ from one amino acid to the other. On the other side we have carboxylic acid, so we need to show all the bonds with COOH, and this is how we are going to show amino acids showing all the bonds. So fine, let's go ahead. The D part, 3 different amino acids are represented as shown in figure 6.3. Here we can say that amino acid A, B and C, all the structures in general are same, only the carbon chain in between is going to differ. So if complete the diagram in figure 6.4 to show the part of structure of a natural polyamide that forms when these 3 amino acids, that is A, B and C, are combining. Show all the atoms and all the bonds in the linkage. So we are going to show all the atoms and all the bonds in especially linkage. Now what are we going to do while forming a polymer from the amino acids or the monomers? We can say that one of the hydrogen is removed from the amine group and the OH group removes from the carboxylic part. So same is going to happen with all the monomers, that is all the amino acids. Now after removing this H and OH, that is water molecule, is eliminated out, the CO and NH part joins up. So if we draw similar way, then NH, if we here NH starting from here, then H is removed, so we just show the extended bond. On the other side we have CO, so I'm drawing the CO, that is the C double bond O. Now that is directly bonded to NH here, so I'm drawing the NH, that is the amine of the second B amino acid, so that is joined here with the B amino acid. On the other side of the amino acid B, we again have a C double bond O group that is bonded with NH group here, so NH bonded here with the third amino acid, the bond is here, and the other side again we have an carboxylic, that is CO group, again an extended bond. So this is how we are going to show the linkage of all the amino acids. Don't forget adding the extended linkage or the extended bond on both sides, because it shows the continuation of the polymers on both sides. So here we draw the structure of the polymer. E is a mixture of 3 amino acids A, B and C can be separated, and the amino acids identified using paper chromatography. Now this is all about paper chromatography. Complete the equation for the RF. Now RF value is something which we calculate from the paper chromatography, and the formula is the distance covered by amino acid or the distance covered by solute upon the distance of covered or of solvent, or distance of traveled, or you can say covered by solvent. You can say even distance traveled by solute, that is fine. So it's main part distance of the solute upon distance of the solvent, and that is the RF value. Let's see what is the next sub question. Okay, F is here. A sample of a mixture of 3 amino acids A, B, C is placed onto a baseline. Now baseline is shown here, that there is a baseline here, and the mixture of this A, B, C is in a solute, like in a solvent form, in a mixture form. A drop is placed on this spot shown here on the baseline. Okay, the finished chromatogram is shown in figure 6.6, that is here. Here we can see the chromatogram, and this is how the chromatography is done, which is the paper chromatogram is dipped in the solvent as shown here. Now the amino acids A, B, C are colorless. Water is the solvent here. So the solvent used is water. Explain why the baseline is drawn in a pencil. Now the only reason is that pencil is insoluble in the solvent, or you can say the graphite or the lead is insoluble in the solvent, so it's not going to participate in the chromatography process, and that's why we use the pencil. Okay, state the type of the substance used to make the colorless amino acids visible on the chromatogram. Now if amino acids are separated on the chromatogram, but if it is colorless, we won't be able to see it, so it won't be visible. So if we want to make it visible, we spray the locating agent on the chromatogram after the chromatography is done, so that we can locate where are the amino acid spots present on the chromatogram. So that's chemical is called locating agent. Now explain why. In figure 6.6, only 2 spots are seen in the mixture of the 3 amino acids. Now here in the mixture paper diagram, we can see that there are only 2 spots and not the 3. While the amino acids present were 3, still only 2 spots are seen. That shows that 2 of the amino acids should have similar RF value. So we can write that 2 of the amino acids might have same RF value, and so they are not separated, they are on the same spot. Now suggest how the experiment can be changed to separate all the 3 amino acids. Now if we change the solvent, then the RF value of the amino acid in this given solvent might be different, and so they can be separated. So if we change the solvent, the amino acids can separate into 3 different spots. And here our paper ends. I hope all the explanation is very clear.